Hi, I'm Prerna, and this is my demonstration of Bitly project for CMP 281. First, let's go through the system design of this project, and then let's go about the demonstration, and then the components, how they're configured on AWS. So a Bitly is basically a system which takes in the long URL and converts it into a short URL. As we can see, the Bitly has three different servers: the control panel server, a redirect server, and a trend server. When the long URL is redirected to the control panel server from the API gateway, it takes the long URL, converts it into a short URL. Now, the control panel server is written in Golang, and it is under an auto-scaling group, and which is configured against an internal network load balancer secured by an API gateway. Once the control panel server converts into a short link, the data is then passed on to an SNS topic called the new short links. And then the new short links has two subscribers, which is AWS SQS, that is the new MySQL and new NoSQL. These SQS queues trigger their respective Lambda function and in turn store the data of newly created short links on AWS RDS and also on the internal and also on an AWS EKS cluster, which is basically a NoSQL database. This database also acts as a cache database for our redirect server. The created short link is then hit on the browser, which goes to the redirect server, which is again in multi-AZ private subnets and under auto-scaling configuration of 0 to 3 instances. This converts, redirects the page, and the data of the used short links is then published onto used SNS queue topic, which has two SQS queues as subscribers. These queues trigger, one of the queues is for used MySQL, which takes the data of the used short links, creates a trigger for the MySQL Lambda, and then stores it onto our primary AWS database. The other queue triggers the MongoDB, and then it sends the data onto the MongoDB, which we have configured on Compass Atlas. This MongoDB is the database which I'm using for the trend server for analysis and analytics of the data of the used short links. This is again in front of a load balancer followed by an auto-scaling group. The control panel, the redirect server and the trend server, all of them have been written in Golang code. The main key highlight of this entire architecture is to maintain or is to achieve a CQRS design, and I have enabled and I have done this by using SNS topics, SQS queues, and AWS Lambda triggers. So now let's go about the demonstration. So let's take a long URL such as probably this, and then hit it on the Postman. And once we hit this, we can we have now seen that it establishes a short URL hash. Now this short URL hash, when it is hit here, it redirects, it is responding and it is giving a HTML. So let's just hit this from the browser. Yes, it is redirecting and it is as expected. So let's go to the databases and see if the data what we actually sent here is reaching our primary and our secondary databases or not. So we can see we hit the Qualcomm URL and it is present on our MySQL database. It also has captured all the details, like from which IP it was hit, from where we hit it from the Postman, and all such details have been configured here. And this Bitly URLs DB basically takes all the data of the new short links which gets created. Now this is our NoSQL, and let's see how the NoSQL database is holding the data. So let's just do a get, And then we see the data which we hit is here. It has the long URL, short URL, created it, and from which user agent it was hit. So all the details of the newly created short links is here. And also to understand how every single node is behaving, I have launched into 5 different nodes of our AWS EKS cluster, and we see that there has been sync requests which is being sent, and the data creation. So we can notice that we are able to see the logs on all of these pods, which means it is hitting and creating a sync, and the data is present on all of them. So now let's look at how the trend server works. And under trend server, I have 4 different links. One is the recent links. So recent links basically tells us the most recently used top 10 URLs. So we hit the Qualcomm and all the details of the top 10 most frequently used one is given here. Now let's see, for a specific link which we now hit, how many times was this link being hit. So that's the data which this particular /links provides us with. So it is telling us that this particular was hit from Postman once, and from the browser another time, and at what time, when, date, all the details of that specific short URL is given under this. And then when we go to the summary, it gives us the total number of clicks of this particular link. So it is showcasing that it was clicked 2 times, one from the Postman and the other browser. So now, so let's say, okay, now let's go about the instances and all the AWS components as to how they are configured. So here we can first look at the EC2 instances. These are the EC2 instances. The control panel is in a private network. We can see that it does not have a public IP, and on the VPC, similarly, the others are also under the private IP addresses. And if we see the load balancers, so we have an internal facing network load balancer, and they are all protected under the same VPC. They do not have any external access. And if we look into the SNS topics, these are the 2 SNS topics, one for new short links and another one for the used. So if you just go through this, also has an policy which says that only it just been made only a VPC private link has been established here, and it behaves something like this, so that all the data which gets into the SNS topic does not go outside of the AWS VPC, and that's how we are making sure that the data which is sent on the SNS topic is secure by creating an AWS private link. And then coming to the SQS, these are the SQS message queues which we have. And yes, if we look at their permission policy, it says only the SNS, Amazon SNS queue topic can only send message. So thereby, even that is made secure. Similarly, the Lambda functions are also specific to the VPC. And then when looking at our NoSQL 5 nodes in NoSQL DB instance, yes, even this is being made secure by creating it under the private instances, and thereby all of these are again secure. Coming to the MongoDB part, we can see that we have a MongoDB network, and this is being made secure by putting it under, by whitelisting a specific IP address, so that no other IP addresses can access this database. As it is not exactly under the AWS VPC, it is still being made secure by using this. Also, this is an example where it shows that for the database use short links, the data is being present here. So yes, all the data of the used short links is stored on this MongoDB, which is used by the trend server for the analytics. Let's quickly go through the GCP model. So this part of the GCP implementation is for the extra credit part, wherein I have implemented the control panel server, the trend server, and the redirect servers on the Google Kubernetes engine. The control panel server communicates with the SNS, and it redirects as usual to the AWS clusters, and then the redirect is secured by an API gateway, and it talks to the NoSQL cluster. And the trend server directly talks to the MongoDB, and that's how it redirects. So let's look at how the instances are here. So we basically have the three servers deployed on Google Kubernetes engine. And then here are the respective worker nodes and the services, which is exposing all of them through the load balancer. So if we now go through the demo, so this is the URL of the network load balancer, and when we hit a post, when a post is being hit on this, a short URL gets created. So this is basically hitting the CP server present in the Google Kubernetes engine, which is internally directing it to the SNS of the AWS, and then that goes into the database part. So this is the short link which gets created. And then now if we want to find the details of about the link, which is given by the trend server. So when we hit this using the recent clicks, yes, so it shows the top 10 recent clicks. So this is connected to a network load balancer of that is present on the Google Kubernetes engine, and it is going to the MongoDB, and from there it is fetching the top 10 most recently used URLs. And then if we go to, oops, yes, so clicks. So how many times this particular link was accessed, it clearly says that it was accessed 2 times with, from where, and all of the details as it used to work on an independent AWS cluster. So all the details are being, these details have been shown by using the code which is running on a Google Kubernetes engine. So some of the challenges faced during this project are implementing a document DB. I tried to implement a document DB instead of a MongoDB, but it did work through the SSH and tunneling, but I had a difficult time connecting it to a document DB in a private cluster using the code. So that was one of the challenges. And yes, the other challenge is when we do a multi-cloud, the securing of all the components gets slightly trickier. So some of them have been connected through a VPC private link, but some of them are secured by the password and then a whitelisting of the IP addresses. Definitely there would be a better way to connect them by doing VPC peering. Thank you.